Hey, and welcome to the Explainer. Today, we are pulling back the curtain on this really revolutionary idea that pretty much changed everything about how we build software. We're going to demystify something called object-oriented programming, or OOP, and its most famous champion, the language Java.
I know. The early 90s? In tech years? That's practically ancient history, right? But believe it or not, this one single concept is the invisible engine running almost everything in your digital life. So the big question is, how? How does an idea from over 30 years ago still power the modern world? Well, let's find out. Okay, so here's our game plan. We're going to start with a tale of two paradigms. What was life like before this big idea? Then we'll jump into the object-oriented revolution itself. After that, we'll see how Java made it something for everyone. We'll uncover its magic trick for running anywhere. And finally, we'll bring it all home and show you where OOP is hiding in your daily life. All right, let's dive into our first part. See, our story really begins with this fundamental conflict in the world of software. It was a real clash of two totally different ways of thinking about how you should even write code.
So before we had all these modern apps, the world ran on something called procedural programming. And honestly, it was a lot like following a recipe. You'd just write this long list of instructions or procedures, and the computer would follow them step by step from top to bottom. It was all about the actions, the functions, the steps you needed to get something done.
And this is where you can really see the problem. The old way, the procedural way, was simple in theory, but man, it got messy, fast. As programs got bigger, the data was just out there. It was totally exposed, vulnerable, basically a security nightmare. And trying to add new features or fix bugs, a huge headache. But then look at the new way. The object-oriented approach completely flipped the script. It said, no, let's focus on protecting the data first. It created these secure little modules, these objects, that made everything way safer and so much easier to work with. So yeah, let's move on to the revolution itself. Because this wasn't just, a small improvement. It was a complete revolution in thinking. Object-oriented programming, or OOP for short, it gave developers a totally new and, frankly, much more powerful way to build software. And a big reason it took off is because it just felt more natural. OOP lets programmers model the real world inside a computer. So instead of just writing these abstract lists of instructions, they can now design programs using objects, things that have their own properties and can do their own actions, just like, things in the real world. Okay, to really get this, we got to talk about the building blocks. And it all starts with a class. The best way to think of a class is like a blueprint. It's not the thing itself. So, for example, it's not an actual dog, but it's the detailed plan that says what makes a dog. It defines everything a dog should have, 4 legs, a tail, and the ability to bark. It's the master plan. So, if the class is the blueprint, then the object is the actual thing you build from that blueprint. It's your specific dog. Let's call him Fido. He's a real living instance created from that dog blueprint. And the cool part is, you can use that one single dog class to create millions of totally unique dog objects. Now this leads us to one of the biggest perks, security. It's a concept called encapsulation. And really, it just means that each object acts like a little protective capsule. It bundles its own data, like, say, a dog's age, and the code that works on that data, like the ability to bark, all together. This means some random piece of code can't just barge in and change the dog's age. Nope, it has to politely ask the dog object to do it. And that's what keeps the data safe and everything working predictably. And that idea of politely asking leads us straight to our next big idea, abstraction. This one is all about simplicity. Think about an ATM. You don't need to know the first thing about how it connects to the bank or verifies your PIN or how the mechanics dispense the cash, right? You just need to see the buttons to press. Well, OOP works exactly the same way. It hides all the messy, complex reality on the inside and just shows you the simple controls you actually need. And finally, there's the one that makes everything super efficient. Inheritance. This is genius. Let's say you already have your dog class. Now you want to make a guide dog class. Do you start from scratch? No way. A guide dog is a dog, so it can just inherit all the basic stuff, the barking, the tail, and then you just add its own special new skills on top. This idea of reusing code, it literally saves programmers a mind-boggling amount of time. Okay, so we've got these brilliant OOP concepts floating around, But ideas need a vehicle, right? They needed a champion to take them mainstream. And that champion turned out to be a brand new language designed from the ground up to do one thing really, really well: be object-oriented. And that language was Java. And the origin story is actually pretty cool. It all starts back in 1991 with this small, secret green team at Sun Microsystems. At first, they called their new language Oak, as a symbol of strength. But turns out that name was already trademarked. So the legend goes that they renamed it Java, inspired by all the coffee they were drinking. By 1995, it was being called a best product of the year, and when it went public in 96, well, the timing couldn't have been more perfect for the web revolution.
And Java took off like a rocket. Why? Because it delivered on some huge promises. People called them the Java buzzwords. It was designed to be simple, way easier to learn than what came before. It was purely object-oriented. It was robust, meaning it caught errors early. And it was secure. Your programs were kind of sandboxed. They couldn't mess with the rest of your computer. But its ultimate superpower, the thing that changed everything, was that it was portable.
And this leads to what is maybe the most famous slogan in programming history: write once, run anywhere. Seriously, this promise felt like actual magic at the time. You have to remember, back then, the digital world was a bunch of separate islands. A program you wrote for a Windows machine was useless on a Mac, and neither of them would work on Linux. It was a total nightmare for developers. So how in the world did they pull it off? Well, it's this clever three-step process. First, the developer writes the code, just like normal. But second, and this is the trick, the compiler doesn't turn it into code for a specific computer. Instead, it creates this intermediate language called bytecode. And then, for the third step, that one bytecode file can be run on any computer: Windows, Mac, Linux, you name it, as long as it has something called the Java Virtual Machine. The JVM, that is the secret sauce. Think of it like a virtual computer that lives inside your real computer. It's the universal translator. So there's a JVM for Windows, a different one for Mac, another one for Linux. And each one knows exactly how to take that one universal bytecode file and translate it into the native language its own computer understands. That is what fulfilled that write once, run anywhere promise. Okay, so that's a lot of theory and tech history. But let's get to the important part. Where do you actually see all this stuff? How does OOP in your daily life actually affect you?
Well, the short answer is pretty much everywhere. Seriously, every single time you use a modern app, you are interacting with a complex world built entirely on these object-oriented principles.
I mean, let's get specific. You know when you're typing in a text editor and the spell check just kind of runs in the background without slowing you down? That's multi-threading, a key Java feature. Or when you send a photo in a chat app, that's using Java's I/O streams to handle the file. Even the friendly user interface on software like Acrobat Reader is often built with Java's GUI frameworks. Or how about when you're on a learning site and you add a course to your collection? Yep, that's the Java Collections framework at work. So what this really means is that right now, as you're listening to this, on your phone, on your laptop, whatever, there are literally millions of tiny little software objects working behind the scenes. You've got button objects, text field objects, network connection objects, all of them bundling up their own data and their own behaviors, all working together seamlessly just to make your digital life possible. And that really brings us to our final question. Now that you know the secret, the next time you open an app, are you going to see just a bunch of buttons and text? Or will you maybe see something more? Will you see the elegant dance of all those little objects and their class blueprints, all working together behind the scenes to make it all happen?